Please remember, the views expressed on Albertans in Space by our guests and hosts alike are opinions and do not represent the entire industry as a whole. Our podcast serves only as a platform, and all topics discussed are primarily for educational purposes only. Welcome to Albertans in Space, the series where we talk to Albertans making waves in the local and global space industry. In today's episode, Mitra joins to talk about what space resources are and the role Alberta plays in the resource conversation. I'm your host, Trolley.
And I'm your co-host and space nut, Meghan Westelmajer. Zach, I am super disappointed. I keep pressing the space bar on my keyboard, but I'm still on Earth. Is there a trick?
Well, being hilarious helps. Good jokes. High five.
High five.
Albertans in Space is filmed in the city of Calgary on Treaty 7 territory. This land, traditionally called Mohkinstsis, belongs to many nations and people who make their home here. And we honor the traditions taught by our elders, to acknowledge the generosity of Mother Earth, and to take care of our land as humanity expands to new worlds.
Hey, Zach, so the universe is made of matter. Can you tell me what is matter and why does it matter?
What's the matter with you?
You're really leaning into the dad jokes, aren't you?
Yep, I will leave the jokes to you from now on. I'm sorry.
It's all I've got.
Matter is a substance made up of various types of particles that occupy physical space and has mass. However, in space, there are different kinds of matter, ones that we can see with the human eye and ones that we cannot, like dark matter. And it's a separate thing. So, in fact, dark matter is this mysterious substance that affects the shapes of the cosmos, and we're still not exactly sure what it is.
Can you elaborate on what dark matter is? Is it like a black hole?
We think dark matter consists of substances from black holes. Normally, matter takes up space and holds mass, so does dark matter. But as far as we can tell, dark matter doesn't reflect, absorb, or radiate light. And the crazy thing is that we think the universe is mostly made up of dark matter.
So what amount does visible matter take up?
Only 15%.
Wow. Hard not to feel important being that 15%.
Right? We're all 15%ers out there. Don't you forget it.
So what's in the other 85%? Interdimensional space travelers?
Maybe. But the crazy thing is, hardly anyone knows anything about it. Scientists theorize that dark matter and dark energy exist in the expanding universe, and it's accelerating. So we've known since the 1920s that the universe is always expanding. In the 1990s, after observing supernovas, astronomers theorized that the universe appears to be expanding much more quickly than it did in the past. And this repulsive gravitational effect seems to be pushing the universe apart instead of pulling it back together, which is how they found dark energy.
That's a lot to take in. Much like a black hole. So what else is up there? Do we have water up in space?
We do. Water can be found in various forms in space, in gaseous, ice, and in liquid form, although much less common. In fact, on October 7th, 2009, NASA found ice on the surface of an asteroid using an infrared telescope.
That's wild. Water is very important for humanity's existence. What else?
A lot. So imagine that Earth is a chocolate chip cookie. And the chocolate chips represent resources like iron and copper or whatever.
Delicious resources.
Delicious resources. And so, humans, we build mines and we go to where these chocolate chips are and we extract them. Well, if we look at things like the asteroid Psyche 16, that is entirely made of metal, almost 90% metal. So the entire thing is one giant block of chocolate. Delicious.
God, that's crazy. That's so much resource.
In fact, things like rare earth metals that we need to power electronics and big generators, spoiler alert, they're only rare on Earth. They're actually super abundant in the solar system. And that's what we're going to talk to Mitra about, space resources. Care to read his bio?
Mitra is a brilliant space lawyer and entrepreneur known for being the CEO and co-founder of Foundation Space Resources. This Calgary-based startup is developing technologies to support the establishment of a permanent human presence on the moon and beyond. Long-term, they aim to develop a sustainable lunar water mine as the foundation of a lunar ecosystem. After graduating from the University of Alberta with a Bachelor of Science, Sean pursued his law degree at Queen's University in Kingston, Ontario. There, he received multiple awards for excellence in international law and completed a thesis on the law of space mining. Since then, his career has covered an array of different areas of law, including competition law, litigation, IP law, and business law. In his free time, Sean is a proud father of an endlessly energetic 2-year-old and an avid martial artist and video game enthusiast.
Sean and I met years ago when I heard there was a space lawyer in Calgary. We got to talking, and we've actually worked together on some space resource initiatives through Foundation Space Resources.
I want to know how Alberta can be a part of the space resource conversation. Does having a deep pool of oil and gas talent help us in that equation?
Well, you know what? I got someone who can help us answer that question. Let's bring Sean on right now. Well, Sean, welcome to the show. Thanks for joining Albertans in Space. First of all, we want to hear from you. Why space? Tell us how you became a space lawyer. What's that journey like?
Great. Well, thanks for having me. As I think was already in the intro, my name is Sean Mitra, CEO and co-founder of Foundation Space Resources. I've always been fascinated with space, science fiction, and sort of all of the above. Since I was a kid, I loved playing sci-fi video games, watching Star Wars, Star Trek, all of the, I guess, typical space nerd things in childhood. When I went to law school, I was really interested in international law broadly. So not just necessarily space, but, the UN, international human rights law, international trade law, the big picture sort of things, I guess both interacting with law on a scale that could hopefully impact more people on a larger scale and dealing with, I guess, bigger questions that impact humanity as a whole, even if they're much slower to be impacted. That's a common criticism of international law, of course, which is, does it do anything? Is it even having any effect? And I think it's one of those things that without it, we very quickly notice it, but with it, it's hard to point out a given instance where it's impacting something today.
So how does all that influence, like all that background in law, how does that influence space? What's the tie-in?
What brought me into space law in particular was actually, I guess, a bit of random happenstance, which is I read an article in The Economist in my second year of law school that was literally about space resources, and it was pretty short, but it was back in the first wave of space mining companies that started to pop up. Planetary Resources was the big one making headlines. And so when it sort of just ended with a sort of throwaway line, and we're going to need a lot of lawyers for this because there's no legal rules established yet, but it's an area of law that's not developed at all. Is international law in minded. And also, if I were to get involved because it's not developed at all, there's a rare opportunity here to touch on the law in a way that is unique to pretty much any other area of law other than maybe the law of AI. And even that is still impacted heavily by existing copyright laws, patent laws. Mm-hmm. And all the other privacy laws, all the stuff that already exists. It's a really unique opportunity to really engage with the law in a way that allows me to hopefully, if I'm successful in having more of an impact, do things right, or at least have a say at the ground level before things get established that are hopefully good precedents rather than bad precedents. It allows me to look at things from a way that's sort of holistic. There's a very direct one-to-one relationship between laws, rules, and perhaps softer things like policies, and how we safely do things in space. Space is hard, space is dangerous, there's a lot of things that can go wrong, and so it allows me to sort of interface with things more holistically, and I think is a really exciting way to engage with the project as a whole.
Well, law is important, as we all know. Like, we structure our life on Earth with law. So I would imagine it would be required when we go into space. Tell us about Foundation Space Resources and what's your mission?
So we were originally founded in 2020 under the name, actually, Lunar Water Supply Company, which sort of represented, I guess, our first more naive approach to the problem, which was that we noticed that there was a lot of really exciting plans to return to the moon and have a permanent human presence there. A lot of those plans called for the establishment of a lunar water mine to provide water both for life support. You can obviously, once purified, drink it, and also break it into oxygen and hydrogen for energy and oxygen to breathe. Mm-hmm. But then also that oxygen and hydrogen can then serve as sort of the base building block for rocket fuel, which then sets the ground for a really exciting long-term vision of an economy that could hopefully be based on, pulling that water out, turning it into rocket fuel, and then enabling further travel, refueling satellites and keeping them in orbit rather than burning them up, and all sorts of other things. And one of the things we really noticed at that time, when looking through all the research, the papers, the guidance put out by NASA, was that it was all very much presented from a aerospace engineer perspective. It was very clear there was very little resource perspective being brought in. For instance, prospecting was just sort of given we'll take 3 samples and that's probably good enough, and very much not what you want to do if you want to spend probably a multi-billion-dollar project hoping to dig up the right spot to find the right resource. And so we really saw an opportunity there to bring, Albertan and Western Canadian resource expertise to the space sector, add a lot of real value to hopefully make these plans more realistic and more efficiently solved rather than having to basically start from scratch. Since then, we've gone through a few iterations as we've tried to find a way to sort of a viable path to revenue in the near term. Of course, that lunar water mine is probably at best the first operation 10 years out. And that's, if everything goes super smoothly. So the big question is, how do you survive as a private entity rather than a research body funded by a university until then? And so we've settled right now on trying to build what we call a digital twin of the lunar environment. So best way to describe it is long-term video game simulation of the lunar environment and as realistic as possible. And so what we see the value there is in both virtual mission planning and virtual testing. Obviously, simulating the lunar environment on Earth is really hard, especially in a physical sort of test chamber. You have to get vacuum sealed, really low temperature, have fake lunar dust there, hope to have somehow simulate the amount of radiation hitting you. And you can't really ever perfectly simulate low grav. With all of those things, we think there's a lot of value to be added today to a lot of these very expensive hardware missions being planned to provide virtual testing mission planning to hopefully reduce the risk by hopefully half or more. And then, that also gives us a platform to then do some virtual tinkering ourselves to sort of identify what is the most sustainable, reliable, and cheapest and most efficient way to establish that lunar water mine, both from the prospecting hardware, the exploration hardware, and the actual mine operation.
I remember people asking me when on my Mars simulated mission, well, how did you change the gravity to simulate Mars? We didn't. We can't do it. We don't have that technology. If we had gravity technology, things would be way different.
And what's cool about the digital twin, and correct me if I'm wrong, because I'm kind of a layman when it comes to the space sector conversation, but it allows people to see things like you put a virtual reality mask on and you get to see the environment, and it represents what it would be like to be on that planet or in space.
Especially in terms of astronaut training, right? If you had a really beautifully done virtual simulation, you could have them not have a perfect, because you still can simulate the gravitational and the physical properties, but you could see, for instance, have them experience a false burst valve on your lunar base and see what happens, and not actually put them in that horribly dangerous situation where there's flowing gas and a vacuum sucking them out.
Totally.
But then they can still actually get some visual experience of what's going on.
It's really cool that you get to fuse your love of video games with your real life now. I'll ask you what the challenges have been for you starting this company, but I would imagine one of those things is funding, and if this is a more affordable option for people to get that funding in the future, then it makes sense, right?
You can't really just send people to the moon to check it out, right? You're like, well, let's go see where our future mine is. We'll send a team out there to survey. Nope.
Has there been more challenges for you?
I think that the largest one, as you say, is funding. I mean, there's a lot of technical challenges to be solved. Surprisingly or unsurprisingly, depending on who you talk to, the really big problem is figuring out how to make this commercially viable and find investors willing to deal with the risk and the long timelines involved. Our current digital twin model is a lot more investor friendly because I really think we could be revenue positive within a year or two if we could get funded to develop it now and secure some customers. But of course, like lunar missions is a much different risk and value proposition than building an app for delivery, right? They're just very different things. And especially in Canada, there isn't a lot of appetite among investors for risk, period. And if you read, investor news, even startups that are just working on earthbound technologies often complain about that, is that, they're looking for very safe investments here in Canada.
Talking about investment, if we're going to be doing a mine here on Earth, if I had a copper mine that I was trying to start up, that's a tough investment. If I tell you I've got a mine on the moon, well, you just went exponentially more difficult.
There are unique aspects to the lunar mine that make it hopefully more intriguing to the right mind of an investor. Mm-hmm. For instance, all the technologies that are associated with it, the value chain you're producing, hopefully the dual use potential you're going to be unearthing, and also the connections with NASA and the space community at large, and building sort of that sort of ecosystem that you might not be able to tap into otherwise. I think there's a lot of interesting value networking, and also I think for me personally, the sort of humanist goal of pushing Earth civilization out to be able to see if we can sustain a presence and bring, as you said, science fiction to reality.
There's always the cool factor. You can never outlook the cool factor.
It's so cool. What are space resources, Sean?
Space resources are, at their core level, exactly what it sounds like. It's pretty much anything you can find in space that is of value for use in any sort of human sense. One of the first questions I always get, though, is, are you bringing that back to Earth? And in my opinion, the answer is no. We are focused on what is called, the acronym is ISRU, which is short for In Situ Resource Utilization. And that just, it's a very fancy way of saying using the stuff you find where you found it. So it's not bringing stuff from the moon back to Earth. It's using the stuff you find in the moon to build things and hopefully reduce risk and costs of shipping it from Earth instead. And so that's what the bulk of the space resource industry as it stands right now is focused on. There are some companies that are still focused on that higher risk, but potentially more exciting play of trying to find super rare materials, bring them back to Earth. My opinion is that that is, if our mission is high risk, that is unbelievably high risk and incredibly difficult to achieve. So I am incredibly skeptical, but it's really a very broad term. And where it really comes into play is there's a difference between a resource reserve and a resource deposit. And so I can get into that terminology, but I think it's, the short of it is just that a deposit just means it's a good amount of that resource that you want underground or wherever you need to get it. A reserve means it's economically accessible. And so that distinction is a good example of what was not really talked about at all in space when I first started doing this. And I was happy to actually see that we've moved the needle a bit, and the conversation at conferences are now actually acknowledging that difference and talking about how do we get to a reserve and not just a resource that exists, but we can't really get to viably.
So you talked earlier about, blending Earth resource experience and aerospace technology. Calgary and Alberta is a big resource, has lots of resource knowledge and experience. How could Alberta play in this new space resource sector? What does that look like?
I think one of the nice things with the space sector that most people don't realize is that it's a lot easier to engage with than you would think. You don't have to go immediately from, doing your resource work to then saying, we're going to pivot our entire company and become experts in launch and all of this stuff. Just like in the resource sector here, space is divided very, very tightly into different specializations. Larger Albertan mining companies, resource companies, engineering firms could get involved as things developed as subcontractors, as research partners, partnering on a pilot project. If they can identify an area of interest that is dual use.
So you don't need to be a rocket scientist to be in the space resource sector?
Not at all. And
okay.
Also, that's also a large part of what we're excited about with the digital twin and sort of our software is to hopefully lower that barrier to entry as well. That, instead of telling someone, go read 500 textbooks, we can say, bring what you know now to this simulation, and hopefully you can then start just playing with and see how things are different and learn at a faster pace that way.
So you have that environment where you can just say, let's see what happens. Let's bring your experience, let's bring your equipment, and let's start playing through these scenarios and see how it goes.
Mm-hmm. Exactly. That's
cool.
Definitely one of the exciting value adds.
So I'm curious to know about the mining process. Can you speak a little bit about mining for energy and mining for critical minerals in space?
I'll just preface this to say that even if we focus on the sort of hydrogen power argument, which is, I think, the more realistic one for mining for energy, it's still not the most energy efficient. The main benefit there is that even though you're burning a ton of energy and effort to get that material, that water out and converting into hydrogen, it's more about having that backup power source, right? Of having a hydrogen fuel cell that you could draw on when there's no sun and your solar panels are going out. If your solar panels, God forbid, get damaged, then you have a backup. That's really where I think the mining for energy part comes out. Helium-3 is understood to be sort of the fuel for what's called a nuclear fusion reactor. And again, running out of my area of expertise, but it's sort of the cold nuclear fusion is sort of a holy grail technology we're at this really exciting inflection point where we have a number of companies, including General Dynamics in Vancouver is the one that I'm most familiar with, that are working on actual cold fusion reactors, where the big difference between that and what we know is our usual nuclear power, which is nuclear fission, which is splitting apart really big molecules like uranium. Nuclear fusion is instead merging them together to produce energy. So the byproduct of nuclear fusion and cold fusion is water rather than radioactive waste. So it's much, much safer long-term. There's no byproduct that's bad, and it's still producing a ton of energy. So it's sort of the clean energy holy grail that if we can figure it out, that will go enormous way to solving a lot of our environmental power concern. Helium-3 is viewed as the fuel for that. It's a rare version or isotope of helium, and there are not insignificant deposits believed to be on the moon for that. And so the argument is that once we have a large demand for helium-3, you could potentially have a supply chain bring that back to Earth to power some of these. The problem is that none of these reactors exist. We don't know how much they'll need. We don't know how extractable that helium-3 is. We don't know how we're going to get off of the moon and back to Earth with large amounts of material. Right now, all we've ever brought back is people and a few small things. It's very different to have an actual supply chain. So the other category is mining water out of the ground, and we're hoping to find it in highly concentrated forms. The holy grail will be literal chunks of ice, but I'm personally a little skeptical we'll find like pure ice blocks. I mean, I'd love to be wrong, but I think we're more likely to find it mixed in with the lunar soil and having to filter it and purify it before we can use it. But all the same, being able to get larger volumes of water out of the ground on the moon would go a long way to supporting that base on the moon that hopefully has a permanent presence. Under the Artemis missions, they're targeting early 2030s. I think about 2032 is the current hope for a permanent base. Launching off of the surface of the Earth, about 90% of a given rocket's capacity is just fuel. That's a lot of weight and power that requires just to get out of Earth's gravity. So even though it is expensive to set up this mine on the moon, the calculation there is really that as hard as it is to do it on the moon, once you get to go reliably, you start getting cost savings versus having to bring fresh water up from the Earth. And then longer term, of course, you need a more sophisticated economy and refinery system on the moon. But if you can start producing rocket fuel, the moon's gravity is about 1/6 Earth's. And so you can either load up with way more stuff or burn a lot less of your fuel to go places faster. Because in space, you're in a vacuum, there's no friction. So the longer you can accelerate until you hit the speed of light, the quicker you'll get somewhere.
Let's take a step back. You mentioned earlier the difference between reserves and resources, and that kind of sounds like a first step. So where's that at? What does that look like?
The sort of the steps that I've been focused on, and you'll see them defined slightly differently, but typically you get this in sort of the mining steps of building a mine. Is step one, prospecting, where on Earth is typically a grad student or multiple grad students walking through a field with like one of those little plungers where they just take hundreds of thousands of samples over the day. You study them all, and that gives you your sort of first pass of best guess where those likely deposits of resources are. After that, the second step is exploration, which is where you pick, let's say, 4 or 5 of your best guesses based on that prospecting effort. And you start doing some deep digging. You bring real machines out to do deep digging. Hopefully, at that point, you'll have found multiple deposits, which is to say, a significant amount of that resource in one spot. So
right.
We'll just stick to water because that's what we've been talking about. So we're hopefully have found lots of water underground in this one spot, whether that's in chunks of ice or high concentrations mixed in with dirt. What you then do to convert that into an actual reserve is you start running the numbers, you develop the technology, and you say, for the cost of building all of this, there's more stuff underground that even for the cost of building that mine, you can pull it out and still make a profit, or it is economically feasible for us to fund this. And I think that definition changes a little bit in the lunar exploration context because your pure goal is not just profit, right? For us as a private operator, we ultimately do need to be able to see that break point of costs versus revenue and hope that we're breaking out on the positive side of things. But as far as space agencies care, they aren't necessarily funding, a for-profit operation. They
Right.
just want to know, can this be cheaper than bringing that water off of Earth, bring that rocket fuel off of Earth, bring that oxygen off of Earth? And so I think that we're going to need to establish a better definition of reserve as we get a bit further along. Right now, the state of things is that we really haven't even done prospecting on the moon. We've done orbital scans with various instruments, and we really need to start taking actual samples from the ground and verifying some of our findings from those various instruments that are scanning by satellite.
Now, when we do resources on Earth, sustainability is also something that comes up and is talked about a lot. How does that fit in a lunar context?
So that's a great question, and that's one that we set out very early on as a company to try and find a definition for. Because that's one of the things we found as well, is that everyone in the lunar circles of different companies, different aspects, everyone's saying they want to be sustainable. Every space agency says part of their core plans are to have a sustainable presence on the moon, but very, very rarely do you see any effort to define what does that mean. So for what that means to us is that sustainability means achieving mission objectives with the minimal footprint possible and with a either reversible impact or a non-impact to surrounding operations and the scientific environment. So obviously digging up a site on the moon will not leave the moon exactly the same form it was before, but we'd like to make sure we're minimizing things like dust ejected, lunar dust is really, really nasty. It's both really sharp, so if it gets in your lungs and cuts you up, it's also very abrasive. You look at like astronauts, the Apollo astronauts, their gear was worn down like crazy, much faster than if they were driving around the Sahara Desert. And it also takes forever to settle, both because the moon's gravity is much lower. There's electrostatic charging that happens there due to the lack of an atmosphere, among other things. So it just sort of floats and is maintained by sort of the electricity, very, very low electricity, not like you're getting zapped, but it's harder for that static electricity to disperse. And so what that could really cause was a thick layer of dust kicked up by your mining site is that within, let's say, about a month, couple of weeks of operation, if you're not doing anything to mitigate that dust, you could soon get a dust layer thick enough to cut across all electronic communications. You can't talk to Earth, can't talk to your base. That would ruin, hopefully, potentially all human activity on that area. And so that's an example of a problem that we haven't really seen anyone talking about. Likewise, just waste management at all, we think is going to be a really serious problem. We're hoping to use the digital twin to solve. We've gotten our deposit. I think our CTO, Kevin, mentioned last to me, I believe we have 2,700 papers that we've archived and reviewed at least some degree. We found one paper dealing with lunar waste and lunar mining waste. And all it says is that, wow, this is a really important topic. Somebody should delve into this more. That's it. And that's all the research that's been done on lunar waste for a mine site. And so these are examples of where we think that there needs to be more pressure on the community to start thinking about these before we get closer to operations. And we're also really hoping that we're going to be able to use the digital twin to spot these problems ahead of time.
So using the digital twin to move forward and think about sustainability and how we're going to operate these things before we get to the moon. Like you said, that's expensive. So let's practice here.
And also both to flag for us unexpected issues that would arise. Like we actually didn't expect the lunar dust thing until Kevin ran the numbers. He's like, wait, this would actually occur way faster than I thought. Like it would be just like within a month. Like we originally thinking it would be a couple of years before the dust would be a big problem, but it's like no, it's like on the scale of just like a month of operating a small to medium-sized mine, not even a large commercial mine. So hopefully running it will allow us to spot unexpected problems and also to simulate really worst case scenarios that you never want to test in real life. Like, for instance, a refining process might release hydrogen sulfide as part of the process if you're not careful. If you don't deal with that, how quick until all your astronauts die in your base if you're just like letting it go, right? That's something that you never want to like model in real life, but virtually for sure you could just let it happen and see how quickly until it gets to an unmanageable level. And that lets you then build in safety benchmarks, right? Of like, okay, obviously death is not acceptable. So how quickly do we have to ask before even, some debilitating effects, like negative effects are happening? Like do you start getting lightheaded after an hour of a leak? How much time do we have to close that leak? Stuff like that.
And this is stuff that the Alberta industry, from working in oil and gas, they have these set standards, and these are things lessons learned that we can bring in from the industry.
Absolutely. Yeah, that was and remains a core belief of our company, is that these are things that have been solved and understood on Earth, and we should really use those as the starting point rather than just trying to draw it all up from scratch.
Are you sure we want to go to the moon, guys? This sounds complicated.
Well, he just said death is not acceptable. So there.
Okay.
I'm sorry. There's also one other aspect of sustainability that I didn't mention that I think is really important too, is also the cultural aspect.
Right.
So that sort of comes in two angles. One, pretty much every society on the moon in their history has some sort of special significance for the moon. It's obviously a very shared cultural heritage. So at the most extreme end, I would be very strongly against any activity that dramatically changes the appearance of the moon. I think that's not likely to happen with any of the realistically planned stuff. But I've seen some really crazy hypothesized ideas bandied about, mostly as thought experiments, like putting a giant reflector array on the moon to beam solar power off the moon to Earth to have a hyper concentrated source of energy. I don't know about you guys, but I don't want a death ray pointed at Earth, even if it solves our power problems.
Yeah, let's skip past the evil genius part and stick to the happy, sustainable.
So there's that aspect, and then there's also things like the Apollo sites. That's the other things. I really strongly believe that we should treat those safely, not upend the existing landing sites. And there's landers that are still there, rovers that are still there. I think that hopefully one day would be lovely tourist attraction for people to come and see when it's safe to visit the moon and go for a walk.
So the moon isn't under any threat if we are going to start mining.
As far as I say no, and certainly not in the near term future, but I hesitate there because that's part of what we want to model, right? Is that we don't want to do things that are unexpectedly damaging to the environment. To go back to the hydrogen sulfide example, is that the moon does have gravity. So if you start releasing gases, hydrogen sulfide or otherwise, we've modeled within, a year of operation, produce a micro atmosphere on the moon, which isn't to say that, you're having the same things as on Earth, preventing stuff from escaping, but that starts to then corrode all the surface of the moon for science. And suddenly things like geology experiments, where you're hoping to take samples on places away from your base, those results would be invalidated because now there's an atmosphere on the moon damaging the surfaces, and now it's not the same materials that would have been untouched. Another area that is currently under debate, which I'm in favor of protecting at least to some degree, is the far side of the moon is radio quiet right now, which is to say that we don't have any stations there. You're not getting radio or satellite chatter. So that makes it really exciting for astronomers to set up a radio telescope on the far side to then do really exciting science that is uninterfered with otherwise. But if we start establishing relay points and all sorts of things, that silence is shattered and you lose that. So it's not like we're going to have at any risk the moon explode or the moon to fall apart, but like there are ways to change it permanently, which could happen surprisingly quickly if we aren't being responsible.
I think this goes right back to, law, what we talked about before. We got to set some ground rules here.
Exactly. And we know we touched on it a little bit in our interview today, but international relations. What are the challenges for Canada as a smaller component of the larger conversation, the bigger global conversation about who's space belongs to and who gets access?
I think the challenges are, when you pull back from the specifics, very similar to our challenges in any area of contested diplomacy, which is that we aren't large enough to put our foot down and say, this is the way it should be. We're always a little bit at the mercy of the larger players, America, the European Union, and China. Right. All of that to say, though, space is, I think, a much more cooperative legal environment than other aspects of international law. We've been cooperating under the Outer Space Treaty going back to the Soviet Union in the 60s, and that treaty has been respected by and large by all of the parties and all the spacefaring nations since then in pretty much every aspect. So the legal status of space resources currently is that there's no clear international law about space resources, whether or not you can mine it, whether or not you can mine it for commercial gain. However, there are 4 countries that have, 4, potentially 5, I'm not sure about the status of South Korea, that passed laws enabling the commercial extraction and sale of space resources. And those are the United States, who were first, and then UAE, Luxembourg, Japan, and I'm not sure about the status of South Korea. They indicated in press releases that they want to, but I'm not sure if the legislation actually passed. All the same, so these are all individual companies that say that, if a company launches from our nation state, we would authorize this activity. And so when the U.S. law was first passed in 2015, the Chinese opposed it quite a bit. And so there was a lot of hypothesis of, are the Chinese going to continue to oppose this? But in 2022, the Chinese tabled a position at the United Nations. So there's a subcommittee called the Committee for the Peaceful Uses of Outer Space, or COPUOS. It's like all things UN, very wordy and hard to write out, but it meets every year to discuss space law issues. And so the Chinese tabled a pretty significant space law position that said, we agree with the commercial extraction of space resources and are on board with coming together to hopefully figure out rules to do this safely. What those rules are still being hashed out, and I believe they said by 2028 they want to have a set of recommendations tabled, which is, in my opinion, a little bit slow, but I guess we'll see what happens.
So we are at basically the very, very beginnings of space resource. This is as ground floor as you can get.
Absolutely. And so in Canada in particular, we have no space resource law, which is something I've been pushing the Canadian government and the Canadian Space Agency on quite a bit, because obviously that also makes investors a little bit skittish, which,
right.
If we say our core business is space resources, why would they invest in us when we can't even tell them it's legal in Canada? Also, pivoting in that regard to the digital twin is nice to say, well, we don't know whether or not it will be legal. We think the Canadian government is going to make it legal. They're signed on to the Artemis Accords, have funded some space resource activity. Seems like they're on board with it. They just haven't gotten around to actual legislation. But all the same, what we're doing right now is definitely legal, because it's illegal to make software in Canada and do software testing. There's no problem at all.
Right. So we're taking it step by step as the industry grows.
I think that there's definitely a tension between the growth of the industry and technology and law and policy struggling to keep up, which you see very much so in the case of AI.
So, Sean, you are a space lawyer, a company co-founder. You have a young child, and you also volunteer with the Zenith Pathways.
Yes.
Can you tell us about that? And are Albertans allowed to participate in this program?
Absolutely. And I'm glad that you asked. So I was one of the founding team members of the Zenith Canada Pathways Fellowship. This is Canada's first and only fellowship targeted at the space industry. And the goal is to promote Canadian undergrad students as they graduate and, well, as they're in undergrad and then shortly after graduation to get internships at Canadian space companies, receive mentorship and other programming. It's modeled after some similar programs in the United States, but really was born from a place of, we're sick and tired of watching Canadian talent leave Canada just to pursue their dreams. And We've got enough space activity going on here that we think that you should be able to pursue that dream here. So applications, we're hoping will be open late August, early September. We're on year number 4 now, which is pretty exciting. And I think it's a great opportunity. We've had a lot of really great things a lot of great feedback from our host companies as well as our students that have gone through it. And hopefully it continues to grow. And yes, open to any Canadian that has gone through an undergrad program in Canada up until I believe it was 3 years post-graduation. Unfortunately, not yet master's students or professional students. We're hopeful to get there one day, but it's a lot of work as volunteers to just manage the undergrad portion.
Right.
And so, yeah, that's all that we have right now.
Sean, what is the impact of a company like Foundation Space Resources being in Calgary?
There's a lot of talk about, the resource sector and how, we need to balance how quickly it can grow with how sustainable it is for the environment. And so I think that working in space resources is the rare opportunity to work on a literal infinite growth potential opportunity. And so if we're successful, this is an industry that long-term could grow infinitely as long as humans continue to expand into the solar system and beyond, where we're able to apply that same style of expertise, oil and gas or resource mining expertise, to this problem. You're not having to tell people to reskill, not having to tell them to, go and learn to code. It's one of my biggest pet peeves when talking about transitioning to new economy. We don't need everyone to code. Not everyone wants to code. So in this case, those are the same skills can be reapplied in a grand growing way. And so I'm very excited to look at that in the broad picture of things, work on infinite growth potential problem for Alberta and for Canada.
At Albertans in Space, we have a little thing here called the book club, and we ask each of our guests to bring a book to the podcast. So what is your book for today's podcast?
So I don't have a physical copy. It's just on my Kindle, but it's The Upside of Stress by Kelly McGonigal. As somebody who both obviously has had to deal with a lot of stress in my life, as most working professionals do, and also somebody who's generally been skeptical a little bit of, a lot of the sort of mindfulness and how to deal with stress guides I've seen out there. It's one of the more science grounded approaches I've seen that has really helped me in my life. And so that's why I like to reference it. She's a clinical psychiatrist by training. And so she talks a lot about she goes back and forth between sort of the life experience aspect of stress and how it can positively impact your life, and also sort of the neurotransmitter and scientific basis for why it can have both negative and positive effects depending on how you approach it. And so I think contrary to a lot of mindfulness stuff, which I found to be, for me at least, a little bit too nebulous to benefit me, there's sort of a core thought to it, which I really like, which is that a lot of the neurotransmitters associated with stress are the exact same neurotransmitters associated with excitement, happiness, and drive. And so often it's your mental framing in that moment of stress that can really change your response to it. And so the mantras that I took from it is, I'm not stressed about this. I'm excited. I'm not stressed. I'm excited. It doesn't always work, but I found it actually does really take me out of that panic state and get me thinking more about what can I do about the situation? What can I resolve? And sort of the other aspect that I liked a lot from the book that I'd love to share is just that you're only ever stressed about something because there's something deeply important to you that's being impacted. And trying to find what important thing is being impacted by this current situation can really make it a lot more manageable, or at least bearable to deal with, even if it's a really stressful situation. So,
and I mean, you mentioned it, and a lot of our guests have mentioned it, that space is hard. This is not an easy industry to be in. And I mean, if you're doing new things, if you're breaking new territory, it's going to be stressful. I mean, if it's easy, then everyone would be doing it. So I think that's a very, very valuable lesson.
And also
to do.
starting your own space company is so challenging.
There's not a lot of people that do that.
So you're compiling how hard it is for yourself. Space is hard. Starting a company is hard. But, it's very good to have these resources for people like yourself so that you can reframe things, look at things a little bit differently, see them as challenges and less as negative stresses.
Yep. Fantastic. Well, Sean, thank you very much for joining us. It was a pleasure to speak with you, and we look forward to seeing how things go and getting ready to have the resources and water available for our summer home on the moon that we're planning on buying.
We'd like to thank Sean for being here today and sharing with us his expertise on space law and space resources. I definitely learned quite a lot today.
Me too. And if you'd like to follow along on Sean Mitra's space startup journey, check out Foundation Space Resources at frs.space.
Thanks a ton to Sandralynn for her writing research efforts, Nick, our sound engineer, 6 Degrees Music and Sound, Dan, our DOP camera, and Kristin, our behind-the-scenes photographer, for helping us make this podcast look and sound amazing.
Thank you, guys.
In our next episode on Albertans in Space, Dr. Michael Gallagher, MD, joins us to give his expert opinion on what a future in space means for humans and how we can keep them happy and healthy.
We don't want grumpy, sick astronauts. I'll tell you that right now.
All of the chocolate chip cookies.
That'll help. That's my solution. Thank you so much for watching Albertans in Space. We hope you enjoyed the show today. Please make sure to subscribe to our YouTube channel and give us a like. We appreciate your support. Now, don't forget to follow us on Instagram at albertansinspace_podcast. See you later.
See you next time. Right on. Good
Thank
job,
you.
man. Good job.
Good episode. Yeah.
Yeah.
Roll those credits.